Example 5. Approximate the sum of the series, the sum from 1 over n to the third power. By using the sum of the first 10 terms, estimate the error involved in this approximation. B. How many terms are required to ensure that the sum is accurate to within 0.0005? A solution in both parts, A and B. We need to know the integral from n to infinity of f of x dx, with f of x equals 1 over x cubed, which satisfy the conditions of the integral test. We have the integral from n to infinity of 1 over x cubed dx equals the limit as t approaches infinity of open bracket negative 1 over 2x cubed close bracket from n to t equals the limit as t approaches infinity of open negative 1 over 2t squared plus 1 over 2n squared close equals 1 over 2n squared. A. Approximating the sum of the series by the 10th partial sum. We have the sum from n equals 1 to infinity of 1 over n cubed is approximating s sub 10 equals 1 over 1 cubed plus 2 over 2 cubed plus 3 over 3 cubed all the way through to 1 over 10 cubed is approximately 1.1975. According to the remainder estimate in 2, we have r sub 10 is less than or equal to the integral from 10 to infinity of 1 over x cubed dx equals 1 over 2 open 10 squared 10 closed squared. So that's 200. 1 equals 1 over 100. So the size of the error is at most 0.005. B. Accuracy to within 0.0005 means that we have to find a value of n such that r sub n is less than or equal to 0.0005. Since r sub n is less than, since big R sub n is less than or equal to big R sub n is less than or equal to the integral from n to infinity of 1 over x cubed dx equals 1 over 2n squared. We want 1 over 2n squared is less than 0.0005. Solving this inequality, we get n squared is greater than 1 over 0.001 equals 1000, or n is greater than the square root of 1000 is approximating 31.6. We need 32 terms to ensure accuracy to within 0.0005. If we add s sub n to each side of the inequalities in 2, we get s sub n plus the integral from 1 of n plus 1 to infinity of f of x dx is less than or equal to s, but s is less than or equal to s sub n plus the integral from n to infinity of f of x dx. Because s sub n plus big R sub n equals s, the inequalities in 3 give a lower bound and an upper bound for s. They provide a more accurate approximation to the sum of the series than the partial sum s sub n does.